Chapter 5 is about energy, but energy is a difficult quantity to define. Often it's approached indirectly by first introducing the idea of work. So that's what we have going on in this first section of Chapter 5. We can get the pen to work. Here we'll have a formula for work. In this case, we want to consider an object, and it's moving through some distance. It has a displacement, and in general, might call that delta R. But while the object is moving sort of from point A to point B, there is a force applied to the object. In this definition, it assumes that this force is constant, and the angle that the force makes with the displacement is theta, in which case the work is defined to be the strength of the force times the length of the displacement times the cosine of the angle between those two vectors. The F cosine theta is really the same, to repeat the picture, as the part of the force vector that is in the direction of motion. This is theta. Then F cosine theta, we might refer to this as the R component, and the work is then just F sub R, that part of the work in the direction of motion. Let's get the delta R back in here, times the delta R. Actually, the force doesn't have to be in the direction of motion. If it is in the direction of motion, then it's going to do positive work. But if the force is going against the direction of motion, then it's going to do negative work. In fact, let's highlight that. Work can be positive or negative. And if we have a situation where the object is moving and the force is assisting the motion of the object, then that's going to be positive work. But in contrast to that, if the object is moving and the force is opposing the motion, that's going to be negative work. And in fact, it's the cosine of the angle that takes that into account. In the positive case, where the theta is acute, the cosine is a positive number. In the negative case, where the theta is obtuse, the cosine is a negative number. So it naturally takes the sign, SIGN, of the work into account. Usually if something can be positive or negative, it can also be zero. I'm going to sneak that in as well. If the object moves, but the force applied to the object is perpendicular to the displacement of the object, now the theta would be 90 degrees, and the cosine of theta is going to be the cosine of 90, and that equals 0. So the full work formula involving that cosine is going to work out to be 0. A couple of special cases. The cosine certainly takes this into account, but it can be a shortcut to treat it this way. In the one-dimensional case, if the displacement and the force are parallel to each other, then the theta is 0, and the work formula is going to end up just being the force times the displacement. The cosine of 0 is 1, so it disappears. And in the case where the displacement is one direction and the force is anti-parallel to that, now we're going to have an angle of 180 degrees. So the theta is 180, and the work, well, the cosine of 180 is -1, and you can pull the negative out and write just the force times the displacement with the negative. So those are shortcuts in the one-dimensional case. Would also be good to mention the SI units for work. And looking at any of the formulas, really. Let's go back to the original. The work is coming from a force times the displacement. The cosine doesn't have a unit in it, so we don't have to think about that one. But in SI units, the work, force times a displacement, is going to be a Newton times a meter. That will be the SI unit of work. So it's a Newton times a meter, but that is given its own special name. That's the joule, abbreviated with an uppercase J. This section also introduces a vocabulary term, and we'll comment on that. A dissipative force is essentially one that creates an energy or actually has to transform one energy into another, but it creates an energy that wants to leave the mechanical system. Kind of the poster child for dissipative force would be friction, because friction generates heat, and the heat energy wants to sneak away from the system, in essence, and that's what makes it a dissipative force.